I'm sure everyone's heard of the Leaning Tower of Pisa, the one that bends like this. And makes people take pictures like this. But have you ever wondered why? That is because the soil isn't made out of equal layers, but they're made out of separate and non-uniform layers like this. So, what should you do when all your soil is weak? Well, one method is we can build a stone column. One of the few methods to construct the stone column is the vibro displacement method. Vibro means vibration, while displacement means this place to that place. First, the metal vibrator attached from the crane is driven into the soil. While doing so, it compresses the surrounding soil and it also displaces the soil to make a void. When it reaches the desired depth, the rocks and gravels are poured from the top through a metal hopper and into the vibrator. The vibrator vibrates while it is being lifted from the soil, compacting the rocks along the way. There are three methods in which a stone column can fail. The first being bulging. Bulging happens when the stones radiate out from the sides of the stone column, effectively reducing the overall length of the stone column. The second failure is the general shear, where the surrounding soil comes up when the load is applied on the stone column. The third failure is the punching failure, where the stone column punches through the solid soil underneath it. One of the proposed methods to overcome the bulging failure is by encasing the stone column, and it doesn't take a rocket scientist to see why. It's pretty straightforward. Encasement provides lateral confinement, which helps retain the shape of the stone column. Naturally, being curious people, we decided to put it to the test. We used 1.5 kilos of sawdust with 6 kilos of water and mixed it in a mixer for 5 minutes to simulate the soil. Next, the icky and gross soil was placed in 3 layers in an aquarium, while being compacted in between. A PVC tube 14 millimeters in diameter was used to core the soil for the stone column. Ceramic filter beads, the ones commonly found in filters, were used to construct the stone column. The simulated soil was so wet, so we weren't able to create a stone column that rests on a hard surface. The stone columns and soils were tested by adding 2 kilo weight plates on it, and the settlement was measured after 3 minutes.
A few moments later.
The soils and stone columns were tested by incrementally adding 2 kilo weight plates, and the settlement was measured after 3 minutes. This process is repeated several times to a maximum of 10 kilos. 2 sets of controls were done in this experiment, one without any stone column and one with an ordinary stone column. 3 different encasement materials for this experiment. First, a regular cotton stocks. Second is a woven geotextile sheet. Lastly is a condom. Yes, that condom. But for the sake of professionalism, it shall be henceforth called as rubber casings. These materials were selected based on their permeability and their elasticity. Based on this graph, you can clearly see the effects of a stone column on the soil. The soil without the stone columns settled drastically, while the ones with a stone columns, regardless of the encasement or encasement materials, showed similar settlement. With this, you can clearly see the effect of encasement on a stone column. The stone column encased with the sock performed better, in which it showed the least settlement compared to the geotextile stone column and the rubber casing stone column. All three encased stone columns performed better than the ones without an encasement. However, it is worth mentioning that for the geotextile encasement, it does not cover all the way to the bottom of the column, while the sock and the rubber casing does. Within the confines of this experiment, we can safely conclude that encasement helps in improving this stone column. The best material for an encasement is an elastic and permeable casing, but in the real world, geotextiles will be preferred because it is widely available. Plus, it's actually built to be buried into the soil. With that being said, that's the end of the video. Thanks for watching.